program is brought to you by Cbm Program Studio, the cross-compiler for all Commodore computer formats. Cbm Program Studio allows you to quickly develop basic programs as well as machine code programs for all the different Commodore computers. It allows you to also define your own character set as well as the sprites that the Commodore 64 uses. Just go to the Cbm Program Studio homepage and you can download the Cbm Program Studio for free from the download page. All I ask is for you to make a generous donation to the efforts of Arthur and his development of Cbm Program Studio. Hello, John here again, and I think this is video 7 in the series of videos to develop a machine code monitor for the Commodore 64 and the VIC-20. In this episode I'm going to be explaining the save command, transfer command, exit, and then the number converters, which are decimal, binary, hexadecimal and octal. So we got quite a bit to cover in this episode. So as you can see, I've got the save code already on the screen, and it's very similar to the load but in reverse. And the difference between and there's a mistake already, I forgot this. Right, let's sort that out. So the save command is you press S and then you put the file name in quotes and then you specify the device number and then you tell it where the start address of memory is and the end address of memory is. So here in this segment we're getting the file name and storing it in context. We save away how many characters the file name is, and then we get 1 byte, which is the device. We then set up the logical file structure. So we say the device number goes in X, we set in logical file number 1 and secondary address number 1. We then get the length of the file name and where it is, and then we set the file name. Then we get a 2-byte number and we store it in add vector and add vector plus 1, and then we get another 2-byte number, but this time we push it onto the stack to store away later and transfer the X, because that's where it is, A and X, and push that onto the stack. Then we do a carriage return on the screen to bring it back to a new line, then pull back what we've just stored away, transfer the A into the Y register, because when we do the save, it's the X and Y is the end location, the end point for the save. We load the accumulator with the 0 page memory location of where the start address is, and then we say do save, and that saves away the file to whichever device, and then we jump to ready. So exactly the same as load, but the only difference is we're then specifying the start address to save and the end address. So we can do this, and we'll just try it out. So here we are in Vice. So we're going to mount, no, we're not going to do that one. We're going to mount an image I've got, so we'll use that one. How many bit? 11 blocks is that? No, I've got a bigger one. There we go, that'll do. And so I've attached the disk, so 496*9. So we're going to save A1000 to C1000 on the disk. So basically we're going to save the basic ROM. So here we go, save basic to device 8 from A1000 to C1000. Right, see if that's done it. Did that do it? Didn't look like it done it, did it? No, it didn't. Why didn't that work? It worked the other night. Store it in a store X and Y. So A is the high, X is low. A is the high, X is low. Transfer A to Y. Load the hash version. Well, I'm going to have to look at that later. It looks right. Yeah, it looks right. Anyway, so we'll go on to transfer, and transfer basically allows you to move a set of memory from one place to another. It doesn't reconstitute any of the jumps or any of the go subs or anything like that. It's just basically copying memory from one place to another. So we can so what we're going to do, so what we're doing is getting the first 2-byte address, which is your start address, the second 2-byte address, which is your end address, and then the third 2-byte address, which is your move to address. So for example, we can do A1000 to C1000, store it in 4000. Yeah, and then what that does, so it sets ADVEC, disend, and HTVEC. So what it's basically doing, it's loading from ADVEC to HDVEC, adding 1 to both of them, and then testing ADVEC with disend until it stops. So it loops round and round and round until it stops. So we can try do that. So transfer so let's look at memory 4000 24100. So you can see just noughts and FFFFs. So we're going to transfer A1000 to C1000 to 4000. Done. Now if I do memory 4000 to 4100, there you go. And that has copied the basic ROM into memory address 4000, but it doesn't change any of the jump vec. It doesn't change any of the JSRs or jump routines. It doesn't relatively change them. It just does a copy of memory from one place to another. So that's transfer. Dead easy, that one. And then we've got another one that's even easier, which is exit. 2 lines, look. So basically it's doing a it's doing a reset of basic and then going back to the ready prompt. And you've probably seen me do X already because I did it when I was in the save when we tried doing it, and that's basically exit. So there, the last 3 commands, I'll figure out what's wrong with the save and I'll do an addendum. And so we come now into the number commands, which allow us to convert one number into another. So the most complicated one is the decimal one, and so what we're doing, we're using some basic ROMs routines to help us out here. And what we're doing is, when you do hash and then the number, then that's what converts it. So what we're doing is, when hash happens, then we're getting a number, and so we're getting a number between 0 and 65535, and there is a routine that allows you to get a number in the basic ROM, which is the line number capture system. and that line, and because you can only have line numbers up to from you could have zero. Oh yeah, you can have 0 to 25535 in BASIC as a line number. So I'm using that basic line number grab routine to get me the number. And what it does, it stores the number it's got into the floating point accumulator. So I get the basic number, and then I tell it where I want to store it. Then we convert the floating point number into an actual integer number, and then we get the address, which then stores it in, I think it's X and Y. Let me just check my book, my Bible. Inline. Here we go. F, and it's get address. Right, this one. So it's converting. So get address is converting a floating point number in FAC1 into a 2-byte integer, which is located in 0-byte location 14 and 15, and registry Y and A. So Y is the low byte, A is the high byte, and that. So I use Y and A to then do all the other calculations. So it does the printing of hex, printing of binary, printing of octal, and then goes to ready. So here I've got also the print of decimal, which basically prints out a hash, then I think that's an equal sign, then a space. It loads A and X, and then I jump to the basic routine, which is a line number print. So the accumulator has the high byte, the X has the low byte, and that routine prints that out as a number in the ROM. So we'll run that so you can see what it does. That's why it's 496.9. So hash 2345. Oops. Hash 2345. There you go. Or hash 23456. There you go. So that's converting a decimal into the other number formats. So the next number format we've got is binary. And basically this is going to load zeros and ones in, and we're going to do some rolling. So rotate left and all that jazz. So the first thing we do is we reset the numbers that we are trying to convert. Then we get in the character. If it's not return, then we go to 3. So we set the carry. We're going to subtract the number 1, and the reason for that is because if you subtract, because when we get it out of the keyboard, it's actually ASCII character number 1. So what we're doing is subtracting ASCII character number 1, and what that does is if it's 1, yeah, it sets the carry, because we're doing ASCII character number 1 minus ASCII character number 1 doesn't borrow the carry, so the carry's still set because we've set it here, yeah, and so that gets rolled into the low byte, and then we roll the high byte with the result of the low, and then we carry on doing that. But if we get to a 0, 0 is ASCII character 30, I think, and then we're going to subtract ASCII character hex 31, which means it goes and borrows the carry, which then clears the carry out. So when that does the roll, it rolls in a 0 rather than a 1. It's very clever. Just a little bit of mathematics, and then what we end up with HT, and which is equivalent to the binary number we've just brought in, And then what we do is we print out the decimal value, print out the hex value, and print out the octal value. Now the binary print is basically the reverse of what we've just explained. So we print out the symbols, and then we store the number into the advec, and basically we'll logically shift left the low byte and rotate left the high byte to then allow us to whatever drops out into the carry. So the carry will be set. So if there's a 1 when we roll it and then we add the 0, it'll actually add 0 and then add the carry, which is 1, which will make ASCII character 1. But if it's a 0, then the carry's clear. So when it adds the ASCII number 0, it is 0 because there's no carry to be added, and then prints out that number, and it does that 16 times and then comes out of it. So I'll show that in a bit. So the hex, very simple because we've got the routines already, because we use them quite a lot. So what we're going to do is we're going to input a 2-byte hex number, store it in HT plus 1 and HT, and then we're going to print out the decimal value, print out the binary value, and print out the octal value. And then the print is we'll use the p byte routine that we've got because we use the hexadecimal print in routine and input routine a lot in the machine comm monitor, so it's dead easy to print this converter. And then the octal one is so you got to remember each digit is a number between 0 and 7 because octal is base 8. So we do the same thing as we did with the binary, and then we get the character in, but this and we do exactly the same as the binary, yeah, but the difference here, right, so we're checking for 0 and then we're rolling that in. So if it's 1 it'll roll in a 1, if it's 0 it rolls in a 0, and that's the first digit, because every other digit after that, because when we do a 655 in octal you'll find out there's one digit that can only be 0 or 1 because of the way it's laid out. It's bit. So that's the first one, and then what we do is we then cycle through all the other characters, which will be 4 other characters. I think there's 5 digits altogether with 4. So we do the same thing here. We set the carry, subtract 0 from the number, which will result in a carry being set or the carry not being set, and then we multiply by 8, which is ROR, 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 ROR. Yeah. And then we roll it into our resulting byte set, and we do that 3 times. So each digit is a multiplication of 8, and then we roll it into the byte, and then we do the typical. Once we've finished, so we've done that 3 times, we do the increase of y 5 times, because that's the number of digits to make sure, and then we print out the decimal value, the hex value, and the binary value. And then the printing out is exactly the reverse. So we roll 1 byte out, roll 1 byte out, and that's the 0 and 1, and then the 4 sets of digits after that have to be divided by 8 to give us a number, and that's what happens here. So let's build it and try them out. So we've done decimal, so binary is the percentage sign, so we're going to do 11001100 space 10101010. There are 2 sets of 8 digits. Press enter. There you go. So we'll do it again, but this time we'll go 00110011 space 11001100. Easy peasy. Hex still the same, so we'll do CC55. So that's come up with exactly the same as before, and we'll do the other one that's worked out as well, 3366. Excellent. And then octal is the @ sign. @ sign. Oh, I've forgotten where the @ sign is. Ah, there it is. So we'll go 3245 6. There you go. So if we do at 1 1 1 1 1 1, yeah, that's right. That's right. So if we do at 1 and then 77777, because it's base 8, 65535. There you go. Excellent. So if we go at 0 7777777 32768, it's 32767. Yep. Excellent. So exit out of that. So there you go. That is, got to figure out that save though. That is all the commands in this machine code monitor. So what I'm going to do is, like I've been doing before, I'll put the complete set of code on my GitHub site and see what you think. Hopefully we'll be able to make a, because I've put it at 9,000, we have to put that in 8,000. I want to make a cartridge, so we'd have to change the starting point. But as a learning thing, I'm hoping that you guys have learnt a lot about writing code for applications rather than games, and please make comments, give me suggestions and stuff like that. All is welcome, and I always listen to everybody, because even though I've been doing this for 30 years, new minds can have new ways of thinking. It's always good, isn't it? So with that being said, if you like the video, please hit that like button. If you don't, well, please unlike it, and I'll put this in the GitHub account. And if you think I'm doing alright, please be a patron. Trying to get some more money together to get a better camera for the real life stuff, and I'll see you in the next video. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.